Hi scholar, welcome to Post Scholar's channel. If you are seeing this video for the first time, you are a special person and I celebrate you with an online case. Mwah. If you are already a subscriber, I love you more. So the title of this video is Conversion from one number base to another, right? Therefore, at the end of this video, you should be able to solve any question involving conversion from one number base to another. Now, we have three questions we are going to solve, and I would like you to follow me thoroughly as I explain each of them. Now, the first question says convert 1011 base 2 to base 5, right? We start by saying solution. Question 1, want to convert 1011 base 2 to base 5. Now, if you check other examples we have been doing, what we usually do is we convert from a particular base to base 10 or from base 10 to another base. But now I want to convert from base 2 to base 5. So the first step is to convert base 2 to base 10. So the first step we are going to do is first convert base 2 to base 10, right? Now, how do we do that? We do that by expanding by writing 1011 base 2 in its place value form. That means we are going to be writing 1011 in the power of 2, right? To do that, first of all, number the digit by saying 0, 1, 2, and 3, right? Then by expanding in the power of 2, we have 1 times 2 raised to power 3. That's for the first one, right? Plus 0 times 2 raised to power 2, right? Plus 1 times 2 raised to power 1, right? Plus lastly 1 times 2 raised to power 0. If you check, we are expanding the power of 2. We have 2 here, and that 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, right? So that's the normal pattern for converting to base 10. Next, we are going to simplify. To simplify, we know that 1 times 2 raised to power 3 is 8, right? Then plus 0 times anything gives 0. Everything here becomes 0. Plus we have 1 times 2 raised to power 1 gives 2. Then plus 1 times 2 raised to power 0 gives 1. So finally, we have 1 times 8 gives 8 plus 0 plus 2 plus 1. And when you sum up, you have 11 base 10. Now we have succeeded in converting 1011 base 2 to a number in base 10, which is 11 base 10. We are not done. Now we need to transform this 11 base 10 to base 5, which is the question, right? Base 5. To do that, we simply divide 11 by 5 and write down the remainder. So secondly, we are going to convert 11 base 10 to base 5. Doing so, we have 11, right? Then, since we are converting to base 5, we are going to be dividing throughout by 5. How many 5 can you find in 11? That's 2, remainder 1. How many 5 can you find in 2? That's 0, remainder what? 2. Then you count from the bottom. So finally, we have succeeded in converting 11 base 10 to a number in what? Base 5, which is 21 base 5. So finally, we have succeeded in converting 1011 base 2 to a number is base 5, which is 21 base 5. I hope it is well understood. The next question, let's check. The next question says convert 202 base 3 to base 8, right? So let's solve quickly. Question 2. We want to convert 202 base 3, right, to base 5. Sorry, to base 8. Now, the first thing we are going to do is we are going to convert 202 base 3 to base 10 first of all, before we now convert it to base 8, right? So the first step, you write out 202 in its expanded form in the power of 3, right? So you start by numbering 0, 1, 2. Remember, it's in base 3. So it becomes 2 times 3, which is the base, raised to power 2, right? Plus 0 times 3 raised to power 1 plus 2 times 3. The next step is to simplify it, right? So we have 2 times 3 raised to power 2 or 3 to the power of 2 gives 9, plus 0 multiplied by any number gives 0, plus, take note, this 0 is not supposed to be here, it's supposed to be inside 3 raised power 0. Same thing, this one is supposed to be 3 raised power 1. All right, so plus 2 times 3 raised power 1 gives 1. And when you further simplify, you have 18 plus 2, which gives 20 base 10. So for the first part, we have converted 202, right, base 3 to a number in base 10, which is 20 base 10. Now, the mission is to convert it to what? To base 8, right? So the next thing we do now is we have to convert this 20 base 10 to base 8. How do you do that? You divide consecutively by 8. You divide 20 consecutively by 8 until you get to 0. So 20, you start 8. How many 8 can you find in 20? That's 2, remainder 4. How many 8 can you find in 2? That's 0, remainder 2. You see, we stop when you get to 0. So we have converted 20 base 10 to a number in base 8. So you count from the bottom, which is 24 base 8. So therefore, we have finally converted 202 base 3 to a number in base 8, which is what? 24 base 8. I hope it is well understood. Now, the last question says convert 2f base 16 to duodecimal, right? So let's solve. Number 3, we want to convert 2f base 16 to duodecimal. By now, you should have been familiar that duodecimal is still the same thing as base 12, while this base 16 is the same thing as hexadecimal, right? Now, since we are working with base 16, if you want to count in base 16, it's simply 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of to write 10, you just write your A, B, C, D, E, F, and you stop there. Then take note, this 0, if you add it to the F, everything becomes 16, right? So this is how to count in base 16, where A represents 10, B represents 11, and on like that. So let's solve having this information. So we want to convert 2f base 16 to duodecimal, right? That we want to convert it to base 12. But before we do that, we have to first of all convert it to base 10. And how do you do that? You have to expand 2f in the power of the base, which is 16. So before I do that, I'll number it by saying here is 0 and here is 1. So I'll have 2 times 16 raised to power 1, right? Plus f times 16 raised to power what? 0, right? Now we all know that f, let's count. C represents 12, D represents 13, E represents 14, and F represents what? 15. That's when you count in hexadecimal. Consequently, we have that 2 times 16. 16 raised to power 1 is still 16, plus F represents 15. So 15 times what? 16 raised to power 0 is what? Is 1, right? So 2 times 16 gives 32, plus 15 times 1 gives 15. And when you add this together, you have 47 base 10. So we have succeeded in converting 2f base 16 to base 10. But we won't stop there because we want to convert it to what? Duodecimal. Since we want to convert to duodecimal, what we do now is we divide 47 consecutively by 12 until we get to 0, right? So that's the second step. So 47, we want to convert to duodecimal, so you divide by 12. How many 12 can you find in 47? That's 3, remainder 11. Now take note, 11 in hexadecimal means what? B. So you see the same thing as B, right? Again, 12, how many 12 can you find in 3? That's 0, remainder 3. So when you count from the bottom, you have succeeded in converting 47 base 10 to a number in base 12 or duodecimal, which is 3b base what? 12, right? So finally, you can present your answer by saying, therefore, 2f base 16 is equals to 3b base what? 12 or in duodecimal. I believe it is well understood. So we have come to the end of this video. Now you should be able to solve any kind of question that takes this format, whether you are preparing for WAEC, JAMB, NECO, or any kind of external exam. I wish you success and I wish to see you in my next video. Bye for now.